What is the difference between adding and multiplying polynomials? We've been talking about multiplying polynomials, but I like to review adding a little bit here and talk about the similarities and differences. Okay, first, adding. X to the fourth plus x to the fifth. Well, we can't really add these. They're not like terms. You have to have like terms in order to add. So this would be just x to the fourth plus y to the fifth, plus x to the fifth. You can't simplify that anymore. However, you can multiply these. X to the fourth times x to the fifth, you use your exponent rule. When you multiply like bases, you add the exponent, so this would be x to the ninth. 3x to the third plus 2x to the third. 3 of them plus 2 of them makes 5 of them. We are allowed to add these because they do have the same ending of x cubed. And there you go. Multiplying 3x cubed times 2x cubed. Well, let's see. Again, just like we just talked about, you can rearrange. Oops, got ahead of myself. So you can make it 3 times 2 times x cubed, which will be 6x to the 6th. So a couple points I want to make about this. When you're adding, you must have like terms. Like up here, we could not do this problem. We didn't have like terms. Also with adding, your endings don't change. Like here, we had our like terms, so we could add them, but the endings just came along almost like a label. 3 of them plus 2 of them makes 5 of them. Multiplying is almost the opposite. When you're multiplying, you don't need like terms. You can multiply any old thing together. X to the 4th times x to the 5th, they don't have to be like terms. They can go together to make x to the 9th. And in multiplying, your endings change. So notice here, we had x to the third and x to the third. We combined them to make x to the 6th. So when you're multiplying, your endings change and you don't need like terms. When you're adding, you have to have like terms, but your endings don't change. So let's practice. Before we practice, let's talk about the laws of exponents that we talked about in the previous video. When you have two like bases that are multiplied, you can combine them together and add the exponents. When you have an exponent raised to another exponent, you can multiply the exponents. I would stop the video at this point, do these practice problems, and then start the video to see if you're right. Negative 8z to the 5th, 5z to the 8th. You can do these more quickly than I do them if you want to. I'm going to write out how to think about them. I like to rearrange the order and then combine what I can. Negative 40, I can think about that as 5z's and 8z's written all out, or I can just use the law of exponents and say, okay, add the 5 and the 8, so that'll be z to the 13th. Notice in all of these problems, everything is all multiplied together. There's no adding or subtracting here. Number 2. X squared, x. When there's just x by itself, it's x to the 1st power. So again, since it's all multiplied together, I can get rid of the parentheses and change the order around. That helps me to kind of organize myself here. X squared times x to the 1st. Multiply like bases, you can add your exponents. That's x to the 3rd. Y to the 11th. Add our exponents. A to the 3rd to the 5th. When I have an exponent raised to another exponent, I can multiply exponents. A to the 15th. Or you can think of it as A written 5 times. How many A's will there be? 15. A to the 15th. Number 4. Let's see, I'll raise each of these pieces to the 4th power. Be careful of this too. You don't multiply 2 times 4. You take negative 2 to the 4th power. That means negative 2 times negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. So this will be 16 a squared to the 4th. An exponent raised to another exponent, I can multiply exponents, so that's a to the 8th. Multiply exponents, b to the 12th. For 5, I'm going to rearrange my order. X, the plain old x, I'm going to write as x to the 1st power. So this will be 12x to the 3rd. Multiply like bases means add your exponents. Okay, I'll raise each of these to the 2nd power. So 3 squared. Be careful, it's not 6. 3 squared means 3 times 3, that's 9. Okay, now a to the 3rd squared. When you have an exponent raised to another exponent, you multiply the exponents. That'll be a to the 6th. 5 times 2 is 10, b to the 10th. There's 2 common wrong answers I'll get here. One, I'll get this, and the other one, I'll get this. Do you see what each person did? This person got this part right, but then they thought, oh, okay, I'm multiplying exponents, so I should multiply the 3 times the 2 to get the 6. Nope, you have to do 3 squared. That should be a 9. This person did that piece right, but then they thought, oh, okay, I'm squaring things, so I should take the 3 and square it and get a 9 here. Nope. When you have an exponent raised to another exponent, you just multiply those 2 numbers. So that's a to the 6th, b to the 10th. So these 2 are both wrong. Be careful of those mistakes. Okay, I like to rearrange here and get rid of the parentheses. Again, that's legal to do because there's only multiplying here. If I had any addition or subtraction, I could not redo the order like I'm doing. Also notice, anytime there was a plain old C or a plain old B, I made it b to the 1st or c to the 1st. Okay, so now let's put stuff together. 6 times 3, that's 18. A to the 4th, a to the 5th. I'm multiplying like bases, so I'll add exponents. B to the 3rd, c to the 8th. Number 8, x squared y to the 3rd to the 5th. So I'll break this up and go piece by piece. When I raise an exponent to another exponent, I multiply exponents. So this will be x to the 10th, y to the 15th. Number 9, b times 4b. Okay, think of this rearranged, 4bb. What does that really mean? Well, bb is b squared, so this is 4b squared. 3x times 4x. Well, let's rearrange 3 times 4 times x times x. Well, x times itself is just x squared, so this is 12x squared.